Hello there, and a very big welcome to Road to Space. We're live at the European Spaceport in French Guiana to launch the next 32 Amazon LEO satellites, traveling on board an Ariane 6 rocket, flight number VA268. Amazon's designation for today's mission is LE-02, LEO Europe 2, as it's the second of 18 launches using the European launch system to help grow the Amazon LEO constellation and connect more people to fast, reliable internet worldwide. It's also the second time we're using the most powerful version yet of Europe's rocket, Ariane 64, with its 4 boosters. And over in mission control, the teams are on console. They're about 16 kilometers from this pad inside what we call the fishbowl, that protective glass that you can see there. I'm Katie Haswell, and joining me is our rocket expert from Ariane Space, Loïc Leroy. Great to have you with us, Loïc.
Great to be here with you, Katie. Hello, everyone.
And Loïc, how's everything looking? What's been happening so far?
Well, so far, everything's looking good. We have the status panel green for the launch. We have targeted now the end of the launch window for today, so we have a new H0, but everything is in track, and the teams are very focused to have this liftoff coming up.
So, flight number VA268 has an exciting journey ahead. Loïc and I will be with you all the way. Of course, we'll be getting a good look at our launch pad. Here it is, the dedicated Ariane 6 launch pad at the European Spaceport in French Guiana. There's our rocket on the pad with its 4 boosters and the satellites up at the top.
And we'll go also to the Launch Control Center, where we have all the teams preparing the launch. They are in charge of all the operations, both on the rocket and on the launch pad. You can see the teams here in Ariane groups preparing for the liftoff.
We'll also be heading over to France and seeing their colleagues back in Paris, just outside Paris actually. It's called Space Code, and these teams are at the Ariane Group headquarters, working in parallel, supporting the teams at the Guiana Space Center.
Yes, and back to the French Guiana and the spaceport, we'll have the quick look telemetry teams working on the launcher telemetry, so they will report to the mission control the very heartbeat of the launcher during this flight.
And they will be very much involved after liftoff. Let's go inside the Mission Control Center now, inside the fishbowl, to David Caballeros. David is the CEO of Ariane Space. David, thanks for coming to chat with us. How are operations progressing for launch?
Hi, Katie. Everything is on track. Our team here at the Guiana Space Centers have performed the final checks. Every systems are green, the weather conditions are favorable, so now Ariane 6 is standing on its pad, equipped with 4 boosters and ready for the launch.
And David, tell us a little bit more about our passengers for today's ride.
Yeah, absolutely. So today, Ariane 6 is carrying on board 32 satellites for our client, Amazon LEO. This is the second launch within a series of 18 that we are doing for Amazon. And I must say that we are very, very proud to support Amazon's ambition to deploy high-quality connected services worldwide.
And David, this is the 7th launch for the Ariane 6 launch vehicle, the rocket. Why is that important?
Well, it demonstrates our ability to quickly ramp up our launch cadence and also to deploy large-scale telecommunication constellation. So I would like to thank our Amazon clients for their continued trust.
Indeed. Thank you very much indeed, David. Best wishes to you now and to all the teams as we get closer to launch. David Carreras, thank you. So, Ariane 6, as we said, has already lifted off 6 times, each launch delivering its satellites absolutely flawlessly. It comes in 2 versions, as we've heard. We've got the 62 version, which has 2 boosters, and the 64 with 4 boosters. We are indeed flying the 64 version today, Loic. It's very powerful.
Yes, it's the second time we're using it, and it's the most powerful rocket in Europe. And it has been designed to deliver over 20 tons to low Earth orbit. This is the kind of orbit we are targeting today with our 32 Amazon LEO satellites. And we definitely need that extra power to lift off.
And if you look at the top of the rocket, you can see the pointed section. We call that the fairing. We have two versions of that as well.
Yes, another versatility feature of Ariane 6 is that we have two types of fairing, a rather short one of 14 meters and an extended version of 20 meters that we are using today as we are accommodating a lot of passengers, 32 of them. We need also that extra length to be able to fit all our satellites inside.
Indeed, so we've got the most powerful version yet of the launcher and the long fairing with our satellites inside. They are scheduled to lift off in just under 22 minutes' time. What's going to happen after that?
So we'll start our journey to space today with the ignition of the 4 boosters of the Ariane 6 rocket alongside the main Vulcan engine. We will lift off from the coast of French Guiana towards the North Atlantic. Then about 2.5 minutes of flight, we will separate the boosters and we'll continue the journey with the propulsion of the main Vulcan engine. About a few seconds after that, we will be exiting the atmosphere, and so we will be able to separate the fairing that is protecting our satellites right now. About 8 minutes of flight, and we will be able to shut down the Vulcan engine. We will have finished with the propulsion on this stage, and we'll separate the main stage, leaving the floor to the main upper stage, which is equipped with the Vinci engine. It's a reignitable engine. We'll use it 3 times during this mission, and the first boost will be about 11 minutes duration. We will then have a coasting phase or ballistic phase. We will reach the ground station in New Zealand and be able to have a second boost of the Vinci engine, a very short one, to be on the right orbit to deliver our satellites. So the separation sequence itself today will last about 25 minutes. It will be divided in 12 steps. We will separate the satellites 3 by 3, 2 by 2, and then eventually the last one. We'll finish over the Atlantic. And once the commercial mission is over, we will enter the last phase of our mission for Ariane 6, which is a third boost of the Vinci engine, and then preparation for re-entry into the atmosphere above the Pacific Ocean. We call it the passivation phase. And this way we don't leave any debris into space.
So that's the plan for today's flight, for today's journey. But right now, the 32 Amazon LEO satellites are nestled inside our rocket, waiting to start their ride. And Amazon LEO is Amazon's low Earth orbit satellite network, isn't it?
Absolutely. The mission is to connect the world through a constellation of satellites in a low Earth orbit, so close to Earth, and they will be delivering fast and reliable internet to people, businesses, and communities, and that's beyond the reach of existing networks.
And even in major cities, getting online isn't always as simple as it sounds. I can vouch for that, living in London. I can walk down the street and in one street I can have great service, and the next street I can find I'm getting really terrible data connections.
Well, surely Amazon LEO can do something for you. But no, seriously, that's true. That poor internet connection that we sometimes face is really a truly invisible barrier, which determines who can learn, work, participate in a world which we increasingly depend on being online, for sure.
We do indeed. So imagine getting high-speed broadband literally wherever you are, whether you're in a remote village, a city street, or even at home. Amazon LEO's momentum continues to accelerate, from signing partnerships across a wide range of industries to plans to bring connectivity directly to mobile devices. And all of this is in the service of one mission: connecting everyone, everywhere.
Amazon LEO,
communities we're doing this for, whether it's rural communities, people on islands, people on mountainsides, really those types of communities we want to connect, plus businesses, remote farmers, remote construction projects. That's really the mission. And then looking at, it's a European rocket with a European supply chain launched from European soil. Yeah, that brings it pretty close to home. It's very exciting.
And if your wife's Italian, I'm hoping you get some very good food.
Usually, yes, absolutely.
In her village. Martijn, every mission has its own identity, it has its own story, whether it's the technology, whether it's the mission patch, whatever it is. Are there any ideas? Was there any innovation, anything that inspired you guys when creating this mission?
Yes, there are. If you look at the mission patch, you'll see a little airplane. So when we took a step back and thought about what Amazon Leo is about, it's about seamless global connectivity wherever you are. And I think the best way to show that is even in a moving plane, thousands of feet up in the air, you can stay connected. So the team is really connected to that. And the icon of the plane really displays the movement, the seamless connectivity, and the global aspect of the constellation we're launching. Nice,
I like that story. And what is it about this technology, would you say, that's going to actually really kind of change people's lives, if you like? Or, what is it about the technology that makes you excited?
Sure. To me, it's how it all comes together. So we have tons of innovation, whether it's in the satellites, the antennas, the ground infrastructure, the way we're working with AWS for our networking. I think if you bring that together and you add in the customer obsession that Amazon has, the trust that people have in Amazon to deliver, I think that's what really will drive the value for our customers. And yeah, we can't wait to get it in our customers' hands.
Indeed. So what's next?
We'll keep building. Job's not done. As Amazon, we have a mission to be the most customer-centric company in the world. When you see that there's billions of people that lack access to one of the fundamental technologies of our time, that's the mission that we're trying to solve. And our solution is Amazon Leo. So the mission as Amazon Leo is to have fast, reliable connectivity wherever people are, to allow communities and businesses to thrive. So today is a big step. It's a very important step, but it's one step of many on what will be a decades-long mission to deliver on that mission.
And what a mission it is. Thank you very much indeed, Martijn, for coming and talking to us about it.
Yeah. Thank you for having me. Cheers.
Thank you. So we are coming up now to the next big moment. That will be the final weather check. That comes at what we call a T-10, 10 minutes before launch. We are on the Amazon rainforest, on the edge of the Amazon rainforest in French Guiana, which is on the northeastern coast of South America. And you can see it there on the screens, the map at the bottom there. And it does get very hot and humid. The weather conditions do have to be right, though, for a launch to go ahead. Loic, what kind of things do we need to actually monitor?
Well, Katie, mostly two main things. We want to monitor it both on ground and in flight in high altitude. We monitor the speed and the direction, and it's mostly for safety reasons. Then there's towers on the pad, which are protecting right now our launcher. But of course, when we will be flying across the atmosphere, we don't want to be struck by any flash of lightning. That would be damageable for the avionics. And if you wonder about the shower rains of Amazonian climate, there's no problem with that.
Well, I'm very glad to hear that, because it rains a lot in the Amazon rainforest. So the fact that rain is not a problem for our rocket is very. So what techniques do we use? I mean, we have a weather station, don't we, here?
We do. We have a weather station and staff dedicated to this full-time in the spaceport. And they're using balloons. They inflate balloons equipped with a lot of sensors, and they will this way get feedback on temperatures, speed of wind, altitude, and direction, and so on. And probably the weather forecast is one of the fewest elements that we don't fully 100% capable of monitoring. But today the weather conditions are green, so it's nice.
Indeed, the weather, we're in the lap of the gods there. We can prepare more than one mission at a time here at this spaceport.
Yes, indeed. We've been very busy because we are preparing several missions in parallel, for example, for our Amazon Leo customers. And yes, we want to be flexible as such to be able to respond to the need of our customers.
Can see all our status panels are green there. The weather status panel is green, so I'll go for launch in the weather department. The launch campaign is the process of preparing the rocket and the satellites. What's been happening?
Well, first of all, the 32 Amazon LEO satellites have arrived mid-March in French Guiana, so about 1 month and a half ago. They were transported to the Space Center. And in parallel, the elements of the launcher, the different parts, have been produced in Europe and sailed over the Atlantic to French Guiana on this specific boat that you see, the Canopy. Of course, the parts of the launcher have been transferred as well to the spaceport, and that marked the beginning of the launch campaign as such. The first very big step was to assemble the two main parts of the central core, so the upper and lower stage. You can see here the Ariane Group teams assembling with a laser precision these two main parts. Then this assembly is transferred to the launch area. You could see that it was assembled horizontally, and of course we need to tilt it vertically to be able to welcome the other parts of the launcher. This is done on the launch pad in a dedicated mobile gantry building. The boosters on their side were prepared separately in safe areas, and once they have been filled with propellant, they have been brought to the launch pad and then assembled on the main core. We have 4 of them today for our mission. In parallel, we have been preparing the fairing. You can see here the logo of our customers being placed on the fairing. The satellites themselves are prepared in a separate building very safely, and they are then transferred to the fairing facility once they are ready. The whole composite, the fairing and the satellites, are transferred then to the launch pad, and of course we have that big moment of mating of the fairing on top of the launcher, which marks, let's say, the final assembly, and we have now a proud Ariane 6 standing on the launch pad.
A proud Ariane 6 indeed, and we could see there on the ground as we looked at those pictures that there's been a bit of rain in Kourou recently. There they are on the pad, the Amazon LEO satellites tucked up inside the fairing with their seatbelts on in first class, waiting patiently for liftoff. Everybody before launch is looking at the status panels. We saw them earlier, all the teams here in the Mission Control Center. The panneaux de verre, as we call them in French. What do they show us?
Yes, as you said, it's a very important board which have several tabs reporting the status of readiness of different parts of the launch component.
À tous de DDO, attention pour la séquence finale lanceur. Top, H0 moins 5 minutes.
Our range operations manager, Xavier Nérou, there announcing the beginning of the synchronized sequence. It's the final go, no-go decision. You'll be hearing Xavier's voice throughout the launch, calling out the major milestones. Everybody across the base will be listening out for him. Obviously, there are lots of facilities, lots of people here at the base, so everybody needs to be focusing on his words. So we are now in what we call the synchronized sequence or the automatic sequence. What's that and what's happening?
Yes, we are in an important moment of the chronology when during these 5 minutes we will prepare the final state of the rocket. So step by step, the ground computers, which are handling a lot of operations right now, we are talking about activation of valves, pressure and checks, avionics, safety checks. They will lead the way to the onboard computer that will become more and more autonomous. And of course, at the end of the road, we have a fully ready launcher ready to lift off.
So we've got lots of teams here at the base. Obviously, we've been seeing the mission control team, but we also have another launch control center, which is closer to the pad. Number of different control rooms, as I said, and the base, we call it the range, all the different facilities, and here are the launch control teams.
Yes, they are the operational team. So they are located about 5 kilometers from the launch pad. They are inside a kind of bunker, which is really reinforced, making them safe from the blast of the launch. And they have been sending all the commands to fill the tank, pressurize the systems, do basically all plant checks to confirm that the launcher is ready. Now they are leaving the way to the computers and the onboard computers of the launcher, which will become autonomous, but they will keep on monitoring all the parameters. We're talking about temperatures, pressures, electrical currents, and they get feedback from this. And of course, in Europe also, you have this Space Code team that is supporting them, and they are looking over the data as well and making sure that everything is going on track.
Very important to have a double set of eyes, if you like, on the consoles. The more people, the better. Getting close now, laser focus across the base. We can see the cryogenic arms there, Louis, clamping onto the rocket. They are pumping liquid oxygen and liquid hydrogen into the launcher, and they're kept at extremely low temperatures.
Yes, indeed. We are using as propellant for the main and upper stage the liquid hydrogen and liquid oxygen. So we are talking about cryogenic fuels. Liquid hydrogen is minus 253 degrees Celsius. So for our US viewers, it's minus 423 degrees Fahrenheit. So pretty cold.
Pretty cold.
And in comparison, the liquid oxygen is only minus 180 degrees. So rather hot, if you like.
Only minus 180. So the white smoke there, those liquids evaporating. We actually ignite the Vulcan engine 7 seconds before we ignite the boosters. That's just to check that it's working fine, so you can count to 7.
À tous de DDO, attention pour moins 1 minute. Top, à 0 moins 1 minute.
We are 1 minute to launch. Our very best wishes now to all the teams and to our 32 Amazon LEO satellites as they get ready to start their journey. Good luck, everyone.
Good luck, Ariane 6, and good luck, Amazon LEO.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Allumage des ESR et décollage. La propulsion est nominale.
The Amazon rainforest. Good views of our most powerful version of the Ariane 64 rocket, and we can see those 4 engines there, Loïc, the 4 boosters. Yes. They're doing all the heavy lifting right now, aren't they?
Yeah, right now they are responsible of more than
La propulsion est nominale.
First liftoff. So basically, they are doing the job right now. Of course, the Vulcan engine is working as well. And just to give you a few figures, each booster carries 142 tons of solid propellant, and it burns in only about 2 minutes. So imagine the power of these boosters. Once they have done their job and they are basically used all their propellant, they will be separated, and the separation sequence of the boosters is initiated automatically by the onboard computer. It detects when the acceleration of the launcher indicates it's time for separation. And today the separation should occur at around 86 kilometers of altitude.
Tous les paramètres à bord sont nominaux.
Good views there from our onboard camera. The range operations manager is telling us that everything is going nominally, everything is going according to plan. And I think we're going to see, I'm hoping that we will see those boosters separating with the cameras.
Yeah, really nice views. Huh? We're lucky the clouds have disappeared a little bit.
It was a bit cloudy when we lifted
at the beginning,
off.
yes. Didn't see much, but now it's really nice.
Coming up now to the separation of those boosters.
Séparation des ESR.
Quite see them there. We have confirmation. The range operations manager has confirmed that we've separated our boosters. So those live images coming to us with a few seconds delay for technical reasons, but that's the boosters moving away.
It's really nice to see these images. It's always a reward for the engineers that who have been working on this project for many, many months. And we have the data, of course, but this kind of images is always a great reward.
La trajectoire est nominale, tous les paramètres à bord sont nominaux.
Next up will be the jettisoning of the fairing. Everything's going normally. The fairing, the top section of the rocket, we saw it on the ground.
Séparation de la coiffe.
Yes, it's a kind of a nose cone of the rocket, and it protects the satellites from the dust, humidity on ground, and of course during the crossing of the atmosphere, the friction of the air, which would be damageable for the satellites. So once we have exited the atmosphere, we can just get rid of the fairing gently. We can see it now.
Yep, we've had it confirmed from the range operations manager. Look how those parts flex as they fall. It comes away in two halves, doesn't it?
Yes, two halves, and this kind of behavior that you see, the way they move is called the breathing modes, because it's very flexible to make sure that they don't break when they separate. But on the other hand, it's also very robust to be able to sustain all the mechanical loads, all the aerothermal loads that they have during the atmosphere, which are really important. So it's a very ingenious design, a mechanical design, this fairing. It's both flexible and robust at the same time.
Quick word about what you can see on the screen here. On the right-hand side, our trajectory. He's telling us that everything's going normally. The trajectory is the green line. The cross is the actual position of our launcher. And then below that, you can see our altitude, 175 kilometers and climbing. Our distance from the pad and our speed at the moment, Loic, we're traveling at, well, over 3 kilometers per second.
Per second, yes. Pretty fast.
Pretty fast. So the captain has now switched off the seatbelt signs. We can see our satellites in this animation on the bottom right of the screen. There's the big tank of fuel, the main stage, and Loic, we can see our satellites there.
Yes, they are exposed to the outer space for the first time now because the fairing has been removed, and we can see the 32 satellites of Amazon LEO. They are assembled on a kind of mast or pole that is the satellite dispenser. It is provided by Amazon, and it is accommodated on a conical structure that you may see in black, which is called the launch vehicle adapter. And this adapter has been specifically reinforced for this mission, since we have a very heavy stack of payload on top. And now you can have a closer view of the Vulcan nozzle. The propulsion right now is done by the lower stage, and we are increasing our altitude. And as you said, Katie, we can see the track of the launcher in yellow, which is perfectly fitting with the planned trajectory in green.
And these animation images on the bottom right are a simulation of what's been planned.
A simulation, indeed, yes. It's computer-generated images, but they are really a reflection of what has been planned in terms of mission analysis and trajectory and attitude of the launcher also. So it really is realistic. You have a good view of what's happening right now in space.
So he's confirmed the acquisition of signal at the naval station. We are tracking the rockets using telemetry. We have ground stations along the flight path, and the rocket is sending a signal to those tracking stations as it flies over. Basically, it's talking to us. It's communicating, if you like.
Yes, it's absolutely right. We are in constant communication with the launcher. It sends us a lot of details about its functioning and, of course, its trajectory and so on. And we are using, as you said, ground tracking station all over the globe. But right now, we are using a tracking station on the sea in the Atlantic. It's called the Naval Tracking Station. So as you guessed, it's a boat and it's equipped with 5 meters diameter antennas mounted on a kind of stabilized platform. So we make sure that even if the weather at sea is not so great and a bit wavy, we have a steady and reliable signal to get. And all these stations, they are managed by the CNES team, so the French Space Agency, and they are managing all these stations all around the globe.
And I guess it's very useful to have a tracking station on a boat because you can take it where you need to, as well as stabilizing it. So the launcher has checked in at the Naval Tracking Station and said hello to the teams there. Coming up to the next big moment, that's the switching off of the Vulcan engine.
Fin de mission sauvegarde. Séparation LLPM. Premier allumage Vinci.
And we have the separation of the main stage confirmed. And we have confirmation now of the switching of the Vinci upper stage engine. There we can see the images on the live camera of the main stage falling away.
Very nice to see this kind of images. Yeah, you can see the lower stage is being ejected and passivated before it re-enters the atmosphere.
So this is a really important moment, isn't it, switching on the upper stage engine?
Yes, we are into the next great phase of this launch. We are using the upper stage, which will be the stage that will raise our altitude, and eventually, with a second boost later on, we will have the last target orbit for our satellites. So now we are performing the first boost. We will boost for about 11 minutes, raise our altitude, and of course, trying to go to the point where we will be able to deliver our satellites.
We're looking here at the camera. We can see the upper stage engine just on the right-hand side there, and kind of slightly glowing as it's burning. So the upper stage is now in charge. Its job is to deliver its passengers to their required dropping-off point, if you like, in space. A bit like an orbital bus driver, isn't it?
Yeah, luxurious.
A luxurious one.
Bus driver, yeah.
With lots of passengers on the bus.
A lot of passengers, and with this Vinci engine that we're able to reignite, we will use 3 boosts for this mission. We are very flexible on this kind of mission, so we will be able to deliver a constellation at the right place at the right time. And this is a really interesting feature of Ariane 6 as such. We are using also cryogenic fuels for this engine. So once again, oxygen, liquid oxygen and liquid hydrogen.
So he's telling us, the range operations manager telling us that the trajectory is nominal, it's normal, and all the parameters on board are nominal. So that's good news. Everything's going according to plan. The tracking stations collect the data from the rockets, and they actually relay it to the teams at the Guiana Space Center, the quick look telemetry teams. We saw them briefly at the beginning. Their tracking station is called Galileo.
Yes, it's a tracking station just outside of the spaceport on a small hill, and they are now collecting all the data in real time that the launcher is sending. That includes, for instance, status of the engine, the speed of the pumps, the pressure of the tanks, the engine thrust, and of course a lot of information on the trajectory, making sure that we are on the right track, and they compare all this data to the actual planned trajectory and simulations. So it allows us to analyze in real time the launcher's behavior, and they report to the mission manager in real time. So we get this feedback from the range operation manager based on their analysis.
You can see them on the bottom right of your screen there, focusing very, very hard. So it's a very demanding job because there's an awful lot of information coming in at once, isn't there?
Yes, a lot. We have, as you see, many people from CNES, Ariane Group, and from Ariane Space.
And they share that information on their internal comms loop, which is then transmitted to the range operations manager, who can then make the announcements. We're going faster and faster, Loic.
Yeah, 5.6 kilometers per second. Don't make me do the maths, please, in kilometers per hour, but it should be rather like 18,000 or something kilometers per hour. So it's a good way to commute. I wish I had that for work.
What's our flight path?
So our flight path today, as we of course said before, we have left French Guiana coast. We have crossed the Atlantic, and we will go above Central Europe, then down Southeast Asia, and above Australia and New Zealand, when we will be able to have the second boost of the Vinci engine. Then we'll have a second fly over South America and the Atlantic, and that's the part when we will be able to separate the spacecraft from Amazon LEO. Then the third big step of this mission will be the passivation and the re-entry, which will happen after another lap of the Earth. It would be happening above the Pacific Ocean.
So we've had the confirmation there that we've picked up the signal at the Santa Maria tracking station, which is in the Azores. Most of the Ariane 6 rockets manufactured in Europe, and the sections are transported to French Guiana by boat. But it's not just any boat.
No, indeed, it's a very innovative boat. It's called Canopy, and it uses both fuel and wind to cross the ocean. You can see on the screen the 4 sails, these 4 masts on the platform, and they use the wind power to save the fuel. We are already saving 40% of fuel, which is a great step for us to reduce our carbon emissions for these transatlantic crossing. It's been sailing around Europe, as you said, collecting the different sections of the rocket that are manufactured in Europe, and then they carry them across the Atlantic to French Guiana. And canopy is a nice nod to the rainforest canopy, which is basically the ceiling of the rainforest.
A very nice nod indeed, and now we have a lovely view of the riverside part of the canopy, the Amazon rainforest canopy. So the tracking station in Santa Maria is now locked onto our rocket's signal. The teams there are tracking our launcher. As I said, it's a Portuguese island in the Azores, in the Atlantic. So let's turn our attention back to our passengers now. You can see them there, our 32 Amazon LEO satellites, as they hurtle through space on their way to their destinations. I'm delighted to be joined by Johan Benner. Johan is the Public Policy Director, Europe Digital at Amazon. Johan, thank you so much for coming to chat with us.
Thank you for having me.
Well, it really is our pleasure. Johan, we are, 14 and a half minutes now into our journey. Anything standing out to you?
Well, I've been shaking a lot for 14 and a half minutes, so I'm not sure I'm done yet with it, but it's amazing to see, the liftoff, and of course the mission is still ongoing, but it's just incredibly exciting. And I've been supporting Amazon LEO for 7 years now, and so to see it go live for real, it's just crazy.
Yeah, that's 7 years. And now here we are today launching. That must be quite an emotional experience. There's an awful lot of expertise in Europe, and this mission brings together a lot of the European capabilities. How important is this mission and this partnership for Amazon LEO?
Well, it's really crucial. It's a global project, Amazon LEO, but it embarks a lot of European technology, and of course, core to that, to that contribution is Arianespace and Ariane 6. But through the Arianespace and Ariane Group supply chain, actually more than 600 businesses across Europe contribute to that project. And there is more because we also manufacture, for example, our satellite dispensers in Europe. So this is really a teamwork from Team Europe.
Indeed, and every mission is teamwork, isn't it? Because there are so many people involved, all working together. Also, I mean, there is also the economic and the industrial side to this. Yeah. And how important is that?
Well, I think it's pretty important, and there are some metrics about that. There is a very significant contribution of that partnership to the European space industry, and that results into thousands of engineers and highly skilled technicians being involved in that project. That also kind of relies on innovation across 13 different European countries. And so that's great for the European space industry. That's also great for the European economy at large. It's billions of additional GDP. But most importantly, because at Amazon, you know, we are customer-centric, it's great for people. There are tens of millions of households still in Europe who are still waiting for reliable broadband connectivity. There is also a key use case for a number of businesses, including at times where redundancy and resilience are absolutely crucial, for example, in case of natural disaster. And this is exactly what Amazon Leo will provide to Europe, that connectivity, that resilience, that redundancy that will serve the communities. And so I will finish here by saying that I'm also very, very much aligned with David Cavalloles, who said after the first launch in February that this partnership actually contributes to European strategic autonomy, because with that new communication system that will provide resilient, reliable communication, with that contribution to the European space industry and the economy, well, that's exactly what we do.
Yeah, very, very important. And what would you, anybody who's watching this now, watching this launch, watching this mission unfold, what would you like them to take away from this?
Well, I'm proud. I very much believe that people who have seen the takeoff are proud as well. Of course, it's still ongoing, so we'll see how it unfolds for the rest of the mission. But that's, I mean, amazing to see the contribution of Europe to a global project like Amazon Leo.
Well, we're very proud to have you here, and thank you very much indeed for joining us, Johan, and very best wishes now for the ongoing mission. Thank you.
Thank you.
So, back to our flight. We are 18 minutes, coming up to 19 minutes to into our journey. We're coming up to the next big moment, which is, of course, the extinction of the upper stage engine, which we've just had confirmed there by our range operations manager. Loïc is back with us. Loïc, why are we switching off the engine now?
So right now we're on an intermediate orbit, an elliptical orbit, so kind of the shape of an egg. The closest point is the perigee, which is 150 kilometers from Earth, and the apogee, which is the furthest point, is at 465 kilometers, and that's the altitude we are targeting today to deliver our Amazon Leo satellites. So it will take us about 52 minutes to climb up to that highest point. And then once we have reached that, we will be able to switch again the engine for a very short boost to make the orbit circular. And that's the targeted orbit for injection of our satellites today.
And the next tracking station scheduled to pick up the signal will be in France at Osagel.
Yes, in the south of France, near Toulouse. So you probably know Toulouse is a great city of aerospace industry in France. It's also a really nice city to visit, made of pink brick walls. If you have ever visited, it's really nice, and honestly, there is also very good food.
It's got a lot going for it. The Pink City, I have visited actually, and it's lovely.
It's lovely, yes.
Right, we are now going to take a break. We, by the way, had the confirmation there that we have picked up the signal at the Osagel tracking station. You can see there we're actually flying over, heading towards France, and then I had a good view there actually of my home country, the UK, flying very close to London, my home city. Right, we're going to take a break now. We will come back in about 45 minutes' time, so don't go away. Stay tuned.
Stay tuned.
Fin d'acquisition de la télémesure par la station de Santa Maria.